class, but it's okay. I will record both classes, but usually I will delete one of them because I don't want the space. We have a limited space for recording. So I will delete one of them and I will keep the another one. Just I will make it a backup in case that one it is not recorded or something like that. Thank you for reminding me. So the derivative of the product, are you really, Shabab, watching the recordings? So what are the percentage of watching the recordings? Are you doing that daily, weekly, or how many students of you they are doing that or not?
I do it sometimes.
Actually, I do it. Yes,
I do it.
I do it when I don't understand the concept. I go and rewatch it.
yes.
There is also, I'd like to mention this in next classes, inshallah. There is also, Shabab, online videos that they already on the Blackboard for the online, similar to the online videos that you had for 001 and 002, if you remember, on the Blackboard, on the online courses. There are also, they are there for forever, not for a specific instructor. They are there. I think they are for Dr. Badr Hamidi and Dr. Jamal Ismail and maybe others, I'm not sure. I will show you this next class, inshallah, because I need to remember that also for the other sections. So when you differentiate the derivative, the product, it will be the first time the derivative of the second plus the second time the derivative of the, also the derivative of the quotient, it is not the quotient of the derivatives. It is the denominator multiplied by the derivative of numerator minus numerator multiplied by the derivative of the denominator over the square of the denominator. What we are going to do today, we will add to them the derivatives of trigonometric functions. You know the trigonometric functions: sine x, cosine, tan, cotan, secant, cosecant. We have 6 trigonometric functions until now. But before that, we will go back to the limits. We will start with reminding you about this limit that we mentioned in section 2.2, and also this limit, because they will be used to prove the derivatives of the trigonometric functions, and also to evaluate some limits that contain trigonometric functions. First of all, we had 2 proofs for this formula, or for this limit. The limit of sine theta over theta when theta goes to 0, it is 1. We prove it numerically on section 2.2. You can use your calculator, ya Shabab. If you ask your calculator to find, for example, 0.00213, for example, small number, it will give you that number again. If you used, of course, the radian mode, approximately. So they are almost sine theta approximately equals to theta if theta very close from 0. So this is what you can conclude. The calculators sometimes they give you wrong answers, errors when you have small quantities. There is a geometrical proof depending on the similarity of triangles and so on. So there is a proof in your book if you are interested in that. It is long. I prefer to skip that proof. So what we are going to prove is this limit now. This is another limit. So before that, ya Shabab, I would like to mention this because we will use it several times. You have to understand this not like that. Sine theta over theta is 1. No. I want you to say like this. The limit of sine any angle, let's call it star. The limit of sine any angle over the same angle when this angle goes to 0 is 1. So because some of you, if we change theta to be another variable or something else, they are not able to use it. So be careful, just understand it in words. The limit of the ratio of sine of any angle over the same angle when this angle goes to 0 is 1. Similarly here, the cosine of angle minus 1 over theta. By the way, this is also true if it is 1 minus cosine theta. So if it is cosine theta or 1 minus cosine theta, the result will be 0 at the end. We will see how. So again, the limit, by direct substitution, ya Shabab, you know, if you direct substitute from the beginning, you will have 0 over 0, because sine 0 is 0 over 0. Similarly here, cosine 0 will be 1, 1 minus 1 will be 0, 0 over 0. So this is undetermined or 0 form. In that case, we need to do some algebraic tricks. Now let's prove this. How to find this limit, ya Shabab? It is 0 over 0. So what do you suggest? We need to find this limit.
From the left.
Theorem.
Multiply by cosine theta plus 1.
Yes, this is a usual trick, ya shabab. You should remember it from math. You have, for example, here angle in whatever. There is a nice trick that you use in math 002, which is multiplying by the conjugate. What is the conjugate of cosine theta minus 1? It is cosine theta plus 1. So this is what you are going to do. Thank you. You're right. So now it will be cosine theta minus 1 times cosine theta plus 1. If you multiply them, you will have cosine squared theta minus 1. And you know what is this? Who can tell me what is this?
Sine squared.
Sine theta. Sine
No.
theta square.
No. Negative, yes. Sine squared theta plus cosine squared theta is 1. So you will have cosine squared minus 1. So it will be cosine squared theta. Bring this one to here and take negative sine squared to the other side. Here it is. You know that 1 minus cosine squared of theta is sine theta. So be careful. 1 minus cosine squared is sine squared. But this is cosine squared minus 1. So it will be negative sine squared. Here it is. Now this is negative is not a problem. You can take it out of the limit. And sine squared, it is sine times sine. This one of them I will put it over theta and the other one over cosine theta plus 1. It is the same. If you multiply this by this, you will have this. If you multiply this by this, you have this. Why I did that? Because now I can separate. I can now distribute the limit. I can find the limit of this one alone and the limit of this one alone because both of them exist. So I will write negative, this negative, limit of this times limit of this. Now what is this, ya shabab? What is the limit of sine theta over theta when theta goes to 0?
1.
Minus
1. Now what is the limit of this one? Can I make a direct
0.
substitution?
Yes.
Let's substitution directly. So this will be sine what? Sine 0 over cosine 0. Sine 0 is what? This will be
0.
0. And cosine 0
Over
is
2.
1. So it will be 0 over 2. It will be 0 over 2, which is 0. 0 times negative 1 is 0.
0.
This is why I told you, Shabab, from the beginning, if it is 1 minus cosine theta, you will have the same answer. This will be 1. It will not be negative 1. This will be sine squared, not negative sine squared. And you will have the same answer at the end. Whatever the number that you will have, it will be multiplied by 0 and it will be 0. So now, no need to do this, Shabab. This one, we did it only once. Now we can use this one. Wherever you have something expression like this, the limit will be 0. When theta goes to 0, be careful. Let's apply them for the derivatives. The derivative of sine x equals to cosine x. This is a new relationship between sine and cosine. They have many identities that in common between them. So they are now having another relationship between them. The derivative of sine x, it is cosine x. If you want to prove it, it is not difficult. What you need to do to prove this, you can use the definition. So your function here is sine x. You need to prove that its derivative is cosine x. So you will use the original definition, 2.8, ya shabab. So what you will do, f prime of x, it is the limit of x plus h minus f of x over h when h goes to 0. Now what is this? It will be sine x plus h minus f of x, it is sine x over h. Now do you remember what is this from math 002? Sine of the sum?
Sine x plus cosine h.
The addition formula. It is sine x cosine h plus cosine sine. You know that sine of the sum, it is sine cosine plus cosine sine. Excellent. Now you can do what? What is the benefit of this step? You can now take this here, sine x, and this sine x as a common factor. You can separate at the beginning, take this term with this term. Here they are. Plus this one over this one and distribute over h. Now take here sine as a common factor and distribute the limit. You can distribute the limit. Now this will be sine x as a common factor. You will have cosine h minus 1 over h. And here you have cosine x sine h over h. When h goes to 0. Now this limit will be what? If you distribute the limits, what you are going to have?
1.
This will be 1. This will be what? What is limit cosine x?
1.
When h goes to 0. No.
Cosine x.
Yes, this is constant, ya shabab. With respect to h, this is constant. There is no h here. This is x. Be careful. Now, what is the limit of this?
0.
0. This is 0 by the previous theorem that I showed you here. This result. Here it is. We just apply it because we have it. If you want to continue, you can multiply by the conjugate, but it is the same. Here it was theta, theta, theta. Here h, h, h. Now, what is the limit of this?
Sin x.
Sin x, it is independent from h. So this is sin x. I think we have them there. Yes, here they are. So this is sin x times 0. Sin x times 0, it will be 0. Plus cosine x times 1, it is cosine x. And we have cosine x at the end. So we have proved that sin x, the derivative of sin x, it is cosine x. It's co-function. The derivative of sine, it's co-function. It's cosine. Any question, Shabab? Is that clear?
What about the opposite?
This will answer your question. What is the derivative of cosine x? It is negative sine x. How to prove it? It is an exercise. You can do the same. It will be cosine x plus h minus cosine x over h. Continue by using cosine x, cosine h minus sine x, sine h. You can continue, Shabab. Do you need me to do that? I want you to do it. Try to do it by yourself, and please tell me about your feeling when you get the right answer at the end. This is one of the what is make mathematics enjoyable. You will enjoy it when you prove and use your previous knowledge and the definitions that you have, the ideas, the tricks that you have to get what you want. Also, the derivative of tan x, it is secant squared x. You can use the original definition of the limit, but of the derivative by using the limits, but there is a better way or an easier way, and it will show you that also the limit, the derivative of tan x, it is secant squared x. And you can notice, Shabab, also, you can also notice, Shabab, that these functions also are friends because there is a relationship between them. Do you remember that 1 plus tan squared x, it is secant squared x? So this can remind you that the derivative of tan is what? Oh, remember, the secant. Okay, there is a relationship between them. So how to prove this, Shabab, in idea? Without using the limit, without the definition. Yes, the quotient rule, thank you. You know, ya Shabab, that tan x, it is sine x over cosine x. Now you will apply the quotient rule because you know the derivative of sine and cosine so far. So we will have, it will be the denominator times the derivative of the numerator minus the numerator multiplied by the derivative of the denominator over the square of the denominator. Now the derivative of sine x is what? Cosine x. The derivative of cosine x, negative sine x. Now simplify cosine times cosine, it will be cosine squared. Negative times negative, it will be positive. Sine times sine, it will be cosine squared plus sine squared. What is this?
1.
1. It will be 1 over cosine squared, which is what?
Secant squared.
Excellent. We have proved that the derivative of tan x, it is secant squared x. You can similarly prove that the derivative of cotan, it is negative cosecant squared. Okay? Please do it at home as a practice. By the same way, because cotan will be cosine x over sine x. Also, you can prove this. What is the derivative of cosecant? What is the derivative of secant? How to prove the derivative of cosecant, ya Shabab? You can use the original definition, but no need. You can prove it as the derivative of 1 over what?
Sine.
Yes, and use the quotient rule. Remember that the derivative of 1 will be 0 because it is a constant. So continue, prove it. I will leave it for you to have it and enjoy it. Really, it will be enjoyable to prove such. Because sometimes you may forget it. Oh, what is it? Is it positive, negative? You can show it. So now you, Shabab, what you need to do, you need to update your table now. Update your table of derivatives. Y prime. Add now these six new derivatives that you have. And notice something. 3 of them are positive, 3 of them are negative. Look. The derivative of sine, positive cosine. The derivative of tan, positive secant. The derivative of secant, it is secant, positive, secant tan. What are the negatives? They are the cosine, cosecant, cotan. These are the negatives. So the functions, the original functions, their derivative is positive something, and the co-functions are negative that thing. Let's take an example about this. The derivative of y equals to x squared sine x. So easy. The derivative is 2x because the derivative of x squared is 2x, and the derivative of sine x, it is cosine x. Is that correct?
No, we have to use the
This
No,
is not
product rule.
correct.
Product.
Yes. We have to use the product rule. The product rule. We have a product of two functions. So now the derivative will be what? The first one multiplied by the derivative of the second plus the second multiplied by the derivative of the first. Now you can do it, of course. The derivative of x squared of sine x, it is cosine x. The derivative of x squared, it is 2x. Why he write it here? It is important. This notation. This is technical mistakes that if you did, it will be you will be in trouble. If you write it this way, you may think that I mean that this is the angle. So you may think that this is the whole angle. So if you want to write it here like this, sine x, you should write dot to x, or write sine x alone inside two brackets, or even if you write this inside the brackets, it will not be clear, sine x, and here you will write it. I also may think that you mean that this is sine of the whole angle. No. So to avoid this, Shabab, it is better to use the idea that the product is commutative. So instead of writing here, it is here, write it here in front of sine. Now it will be clear what is the angle. The angle is x. This is important, Shabab. And also it is important to write sine what? Because I noticed in Math 002 that many of you, they write just sine, cosine. Cosine what? Sine what? You have to specify what is your angle, because this will make difference if you have different angles. So if you just write sine without anything inside it or cosine, I will not consider it correct. Let's take now another example. Differentiate this function. For what values of x does the graph of f has a horizontal tangent? So we need to find the values of x for which we have a horizontal tangent, which means that the values of x for which the derivative, the first derivative, is 0. So we need to simplify the derivative. We will not just find it, because we need to solve an equation that contains the derivative. So any idea, Shabab, how to find the derivative of this one? Which rule are we going to use at the beginning?
Quotient rule.
Quotient rule.
Quotient rule. So it will be the numerator multiplied by the derivative of the denominator multiplied by the derivative of the denominator minus the numerator multiplied by the derivative of the denominator over the square of the denominator. Let's do it now. What is the derivative of secant x? Let's go back. The derivative of secant x, ya shabab, it is itself multiplied by tan. Also the derivative of cosecant, it is itself multiplied by negative cotan. So the derivative of secant is what? Secant tan. Secant x, tan x. And the derivative of 1 is 0. The derivative of tan, it is secant squared. So this is the derivative of this expression. It is here. It is secant squared only. Now, this is the derivative. You need to simplify, because you need to solve, at the end, you need to solve an equation like this, f prime of x equals to 0. So simplify your derivative to be able to solve such equation. How to simplify? You can distribute now. Distribute the 1, multiply this by 1 and this by 1, and also here it will be secant cubed. Or do what your textbook is doing. He takes secant here as a common factor, I think. Yes, you can take secant, this secant as a common factor. What you will have here? You will have 1 plus tan multiplied by tan. So it will be tan plus tan squared. Minus this factored out as a common factor. You have secant squared. Okay. Now how to proceed? How to continue? What is this? Do you remember what is this? What is the relationship between them? We have
minus 1.
1 plus tan squared of x is equals to secant squared x. This is what you need to remember. 1 plus tan squared is secant squared. So what? So this means that if I
Minus
take the 1 to there and the secant to here, I will have
Minus.
tan squared of x minus secant squared of x equals to -1. So this is just -1. So what I will have secant x times tan x minus 1. Another way, you can think about it in a different way. Tan squared will be what? It will be secant squared of x minus 1. Am I right? Tan squared, here it is, tan squared, take 1 to there. Just take the 1 to there. It will be what? Tan squared of x will be secant squared of x minus 1. Now, this secant will be cancelled with this negative secant, and you'll have -1. So in both cases, this expression simplifies to tan x minus 1. Can you simplify more? Of course not. You will stop here now. Now what you will do to find the horizontal tangents, f have a horizontal tangent, f has, it is not have. F has a horizontal tangent if f prime of x equals to what?
0.
0.
It is a mistake even in the question. He asking, oh, he did that for what values? The graph, it's okay. Now, so the f has a horizontal tangent if f prime of x equals to what? To 0. F prime of x equals to 0. So this means that this expression equals to 0. So this is what we are going to do. This equals to 0. Now, if you have a shabab a over b equals to 0, so which one is 0, a or b?
A only.
A. 0.
Means that the numerator is 0. So also here. So this means that the numerator is 0. The denominator, it cannot be 0. If it is 0, it is undefined. So the numerator is 0 means that secant x tan x equals to 0. Is secant x can be 0? Because this means that this is 0 or this is 0?
No. It cannot
No,
be
no.
0.
Yeah.
Secant x cannot be 0. You remember
1
the graph?
over sine.
The graph of secant, it is never ever intersect the x-axis. Not only that, if you want to solve this equation, what you will do? What is secant? Secant
1
is
over sine.
1 over cosine.
1 over cosine.
1 over cosine, it cannot be 0 because the numerator is 1. So it cannot be 0, it is 1. So this one, secant x is not 0. So secant x cannot be 0. You can divide both sides by it, خلاص, done. So this is 0, which means that tan x is 1. Tan x equals to 1. What is x?
45.
Pi over 4.
Pi over 4.
Over 4. Not only pi over 4 plus the period of tan plus n pi. I prefer to write that one here better than at the beginning, where n here is an integer. So these are the values of x at which we have horizontal asymptote for this function, horizontal tangents for this function. Any question, ya shabab? So far so good. So let's go. Here we have an application, physical application for the derivatives. We have an object that at the end of a vertical spring, this is the object and this is the spring, is stretched 4 centimeters beyond its rest position and released at time t equals 0. In this figure, the downward direction is the positive. So when it goes, this is the positive direction, this is the negative direction. It goes back. This is the function of the position function. And usually when you have springs like this, usually the position function will be described by sine or cosine, because these functions are isolating. And this is exactly what is happening here. Look, the isolating function here, it will be isolated. When you have the motion, here it will be isolating. We need to find the velocity and the acceleration. You know that the velocity is just the derivative of the position function. So the derivative of 4 cosine t. Do you need to apply the product rule or no need? Just it is 4 multiplied by the derivative of cosine t. Usually when we have a constant, when we have cf prime, it will be cf prime. So you will just take the 4 out. No need to apply the product rule. You can, but no need. So this will be just 4 cosine t. So the derivative of cosine t. What is the derivative of cosine t?
Minus sine t.
Minus sine t. So at the end you will have negative 4 sine t. Here it is. This is the velocity. It doesn't mean that it is negative. It depends on sine t. Sine t could be negative, could be negative. So it depends on the sign of sine t. The acceleration is the first derivative of the velocity, which will be the second derivative of the position function. The derivative of negative 4 sine t, it will be what? It will be negative 4. Let me write it here down. It will be equals to negative 4 because this is constant. And sine t, what is the derivative of sine t?
Cosine t.
Sine t. So the answer will be negative 4 cosine t. Again, it depends on cosine. The acceleration here depends on, it is a cosine function. And it will be with opposite sign of the position function. If the position function is positive, this will be negative and vice versa. So this is, you can analyze the motion of this object. This is the position function, the acceleration, the velocity. And the speed will be diamond, the speed will be always positive. So the speed is the absolute value of the velocity. Please, ya shabab, mute your mic. You don't need.
طاولة.
Mute your mic, ya shabab. Mute your mic. Who is talking? I can mute him. Yeah, Ali. Mute your mic, yeah, Ali. I will mute you anyway. Let's continue now. Is that clear, Shabab? You know this from before. We had it from before. Now let's find the 27th derivative of cosine x. This is too much. How to find the 27th derivative? Who can tell me what is it? What is the 27th derivative of cosine x? It is not easy to find it immediately like that. What you need to do if you have such questions, ya Shabab, is to find the first, the second, the third, the few derivatives at the beginning and try to figure a pattern for these derivatives, how they will behave when you have n derivatives. So let's start with the first derivative. The first derivative is negative sign. You know that if your function is cosine x, so our function is cosine x. Now the first derivative is negative sign. The second derivative will be what? Who can tell me?
Minus cosine.
Minus cosine.
It will be negative cosine. The third,
Sine.
Sine.
negative sign. It will be positive sign, because you know that the derivative of cosine is negative sign. Now, can you guess the pattern or not yet?
Yeah,
This is a clear pattern. The pattern is not clear for me. What it could be cosine, negative sign, negative. Oh, let's take the fourth one. What is the fourth derivative?
Cosine x.
Sine x.
I'm back now. Look, I'm back to my original definition, the function. Now, if I find the fifth, what will be the fifth? It will be the same. This will be the fifth. This will be the sixth, the seventh. So it will be repeated. And when I who can tell me what is the eighth derivative?
Cosine x.
It will be the same as the derivative of the fourth derivative. So now wherever you have the fourth derivative, the function will restart. It will restart again. So you will do this process just for the first, second, third, and you will go back to your function. Then fifth, sixth, seventh, and then your function back. So what we conclude from this, we conclude,
It will be sine x.
we conclude that the nth derivative of x, it is cosine x if n is a multiple of what?
Of 4.
Of 4. So if it is 8, 12, 16, 16, 20, 24, 28. So here we have the 27th derivative. So it's similar to the I, the powers of I, if you remember in the complex numbers here. So what I will do to find the derivative number 27, there are two options. I will look at the lowest multiple of 4 that is next to this one. What is it? It is f of 24. I think this is what he did in your book. So he just said that the derivative of the 24th derivative of x, it is cosine x. Why? Because the 24 is a multiple of 4. So now you can find out what will be the 25 derivative, the 26, the 27 from here. So which one of them will be? It will be this one. Am I right?
Yes.
The 27th derivative will be sine x. The another way is just divide 27 by 4. You will multiply by 6, it will be 24. What is the remainder?
3.
So this will be equals, where it is, this one. It will be equals to the third derivative of x, which is here, you have it, which is sine x. So it is important to have a pattern. And this pattern, it is not always, it could be different. When you have sine, it will be different. When you have another functions, it is not always possible to have the pattern for all the functions. But so far, until now, we have what? We have a pattern for functions containing polynomials with e to the power x. Also for polynomials, when you have x to the power n plus plus, you can have a pattern for that. Also for the sine and the cosine. Until now, you can, of course, use the pattern of these such type of functions. We will go back now to the limits that we had in chapter 2. How to find the limit of this one? Who can tell me what is the limit of this one? Can you guess what is it? It is 7 over 4.
Yes.
We will see how. It is 7 over 4. And when you have problem like this, you can do it immediately like this, if it is, of course, not written. Now, what we have until now, we know that the limit of sine theta over theta when theta goes to 0, it is 1. How to apply this? Can we apply it now? Is this theta?
Yes.
Is this theta?
No.
If this is theta, this is not theta.
Yes.
So it is important. It is not. If you said it is 1, this is wrong. It is not 1 because it is clear. You should have sine theta over the same theta. So we don't have the same theta. I wish this is 7. If this is 7 يا شباب, لو كانت هذه 7, it will be, this is theta, and when x goes to 0, 7x will goes where? لما x goes to 0, 7x, when you multiply by 7, it will be 7 times 0, it will be 0. So when you have x goes to 0, 7x also will goes to 0. So this will be also theta. So you will have sine theta over theta, but this is not the case here. What you should do, you should have it like the sine angle over the same angle. What I will do, I will multiply by 1, but not any one. I need a hero one. My hero here is 7 over 7. So I will write it just limit x goes to 0 for 7 over 7. I did already multiply by 7 over 7. What I will do, I will take this 7 to be multiplied by 4. So this, what I'm going to do, I will write 1 over 4 or 7 over 4, this 7. And sine 7x over 7x. What I did, this 4, ya shabab, it is 7 over 4. And this 7 multiplied by x is 7x. Now this will be 1. It was the same angle over the same angle when this angle goes to 0. And this will be 7 over 4. It is a constant. It will go out of the limit. It is written here. So what we will do, we will multiply and divide by 7. Why 7? Because I want, this is the coefficient of what is inside. So it will be 7 over 4 sine x over sine x. Be careful, ya shabab, when you have sine x, sine 2x over 2. Can you cancel this 2 with this 2?
No.
No,
No, it's inside the angle, ya shabab. If it is like here, if it is like this, if it is sine x over 2 and the 2 is out, yes, you can. But here it is inside the angle. Be careful. This is a common mistake some students are doing. So now what we have, shabab, we have 7 over 4, and this will be 7 sine 7x over 7x. What we did, we just multiply by 7 and divide by 7. So this 7 will go over 4, and this will be go over 7. Now the limit of this one is 1. You need just to check, is your angle goes to 0? Because you know, if you bought a theta, you can make a substitution. Bought theta equals to 7x. Now when x goes to 0, theta will goes to 0 also. So you can write this one as 7 over 4 limit theta goes to 0 of sine theta over theta, which is 1. So it is 7 over 4 times 1, which is 7 over 4. What we conclude from this, ya shabab, that when you have here A and here you have B, what will be the result?
A over B.
A over B.
A over B.
Here it is. I have written this for you here. So you can use it immediately to save your time. Now the limit of x cotan x. By the way, Shabab, don't forget always the direct substitution first. Sometimes you don't need it. For example, if this limit without x here, if it is without x, what it will be?
0.
0 by the direct substitution. So always, Shabab, don't forget the direct substitution at the beginning. Usually we do these tricks when we have 0 over 0, when we have infinity over infinity, infinity minus infinity, when we have forms that they are undetermined. Yes, it's important. So now here, what do you have if you make a direct substitution? You will have 0 times what? Cotan x, it is cosine over sine. So it is cosine x over sine 0 over sine 0. So what is it? It is 0 times 1 over 0. So it is 0 over 0. It looks 0 over infinity, but this infinity, it is 1 over 0. So it is 0 over 0. 0 over, by the way, 0 times infinity in the case of limits, it is not 0. Be careful, Shabab. It could be, but it is not in general. Because this infinity, it is 1 over 0. And this 0, it is 1 over infinity. So it will be infinity over infinity or 0 over 0. So by the direct substitution, it doesn't work. We don't have an answer. So what we will do, we will write cotan as cosine over sine. This is step number 1. It is natural. Now how to proceed? Can I distribute the limit? Can I write it like limit x goes to 0, x over sine x times cosine x? Is this limit exist when x goes to 0? What it will be?
1.
It will be 1. And what about this?
It's 1.
It is
will
only
be 1.
We have studied, ya Shabab, that the limit of sine theta over theta, it is 1. But I didn't mention that the limit of theta over sine theta. But I said for you that sine theta, it is approximately theta when theta goes to 0. So you can use it. But if you don't like to use the formula that you are not sure about, what you can do, small trick to use this one. I need to use this one here. What I will do, I will divide both numerator and denominator by x. So now this x will be cancelled with this x, and this is what you are going to have. You will have cosine x over sine x sine x. Now the limit here exists. The limit here exists. You can distribute using the quotient law of limits. Now what you have in the denominator will be 1 over 1, which will be 1 at the end. So we can conclude now. I will add it here for you. You can conclude also that the limit of sine theta over sine of theta over sine theta is 1 when theta goes to 0. Not only that, did you notice that limit x cotan x when x goes to 0, it is just limit x goes to 0 for x over tan x? Because what is cotan? It is 1 over tan. So also limit x over tan x when x goes to 0, it is equals to what? To 1. Which also lead us to another conclusion, that the limit of tan theta over theta when theta goes to 0 is 1. And or theta over tan theta, the same. So this is only a Shabab for sine and tan. It is not for cosine. It is not for cosine. Now, how to prove this? It is not difficult. The limit, it will be the limit of tan theta over theta. It will be the limit of what? Sine theta over cosine theta. This is tan and this is theta. Now the limit here, it will be the limit when theta goes to 0 for sine theta over theta times 1 over cosine theta. What is the limit of this one? 1 times 1 over 0, 1 over cosine 0, 1 over cosine 0. Cosine 0 is 1, 1 over 1 is 1. So it is 1. Okay, this is the end, ya Shabab. This is all what we have for today. This is the 3.3. It is very interesting and easy section, but of course there are many tricks that you need here. The most part here important is the summary, is what we have here. These are the 6 new derivatives that we have for today, and these are the new limits that we have. I will add here the one, I forget to write it here. Limit theta goes to 0 for cosine theta minus 1 over theta, which is equals to what? Do you remember? This equals to what?
0.
0. Now, because you need it, you will need it several times. Also, this is the main one, and these are just results. All of these are coming from this one, all of them. So no need to remember all of them. You can, of course, just remember this one, and you can conclude the others from that. Excellent. Do we have time? 5 minutes, it will not be enough. Let's take this one, the next one. I will give you, Shabab, 1 minute, please. It is very easy. 1 minute is enough. Let me launch polling for you. Very easy limit. Just find this limit by using the ideas that we have learned so far until now. Any hint to start? What you should do first at the beginning, Shabab?
Take tan as a common factor.
At the beginning, you have to use the direct substitution. In many problems, there are tricks. It might be you don't need to do anything, just direct substitution. So first of all, try the direct substitution. If you get 0 over a number, or a number over 0, or a number over a number, it's okay. But if you had 0 over 0, infinity over infinity, 0 times infinity, infinity times 0, and infinity minus infinity, so on, it will not be clear. So by the direct substitution, it's clear that tan 0 is 0. So this will be 0, this will be 0 over 0, 0 over 0. So what is the hint that you said? What you said, Ya Ali?
Take tan as a common factor.
Factor tan as a common factor. Good idea. Yes. This is the idea. Continue, Ya Shabab. MashaAllah, I can see that 9 students answered the question. 10. But only few of them are correct. Now, like 50-50, 50% of the students got the right answer.
Doctor,
Yes.
the ball didn't appear to me.
I don't know what is the problem. What is your device? Is it Mac?
No.
I think people with Mac, they have problem with this. Some of them, not all, or Linux sometimes they are using. It should be there. Let me end the polling now and share with you the results. MashaAllah, 50% of you, they got the right answer. The right answer is A. The answer is A. And 15 students obtain it. Excellent, Ya Shabab. The question is, what about the others? Why they got the wrong answer? Or they are just guessing? This is not good. Let me stop sharing and start solving. Now, what you will do, as we said, Ya Shabab, you will take limit x goes to 0. You will take tan x as a common factor. You will have 1 minus cosine squared 2x over x cubed. Now, this equals to what? Limit x goes to 0. Look, Ya Shabab, it is important. If some of you, they don't write this. They write it like this. I will consider it wrong. If you write tan with or sine or cosine without anything inside it, I will consider it wrong. Because here you will make a mistake if you didn't write what is the argument of the function. Now, what is 1 minus cosine squared, Ya Shabab? It is sine squared. Sine squared what?
2x.
2x. This is the trick. If you didn't write it, you will make a mistake. Over x cubed. This x cubed, by the way, it is just x times x squared. Why I did that? Because I know this limit, what is it? And I know this limit, what is it? So now what I will do, I can do it in two different ways. This is limit x goes to 0 for tan x over x times the limit when x goes to 0. I can make it sine 2x multiplied by sine 2x over x over x. So I did distribute the x for all of them. And we have distributed the limit because all of them are exist. Now, this is one way. The other way is to make it just square. It will be the limit. Let me finish. First of all, let me finish this method that I told you about. Sine 2x over x. Now, this will be equals to what? 1. And this one? Sine 2x over x?
2.
It will be 2. For this one, it will be 2. 2
Also
times 2 times 4. The another way, Shabab, is to just make it square. It will be limit sine 2x over x all squared. And in this case, you can just make the limit of all and this square. It will be t all squared times 1, which is 4. If you forget to write the argument, you will make a mistake here. You will consider it as 1. But unfortunately, they didn't put 1 in the choices to confuse you. They remove it from the choices. This is all what we have for today, ya Shabab. Thank you very much and enjoy your weekend. If you have any questions, I have like 1 minute before I leave to go join another class. Any question, ya Shabab?
Thank you.
Doctor,
Yes.
how can I know my attendance?
Remind me next class, ya Shabab. I can show you. If you don't know your attendance, who will know?
No, I know, but sometimes I might just go for the toilet or do something.
You are not allowed to do that يا شباب during the class. يعني هي ما حبكت ما تروح لوقت الكلاس.
Yes,
This is
sometimes.
this is not an